Hello there, and welcome back to the Sleep Science. You're standing outside in the thin hush before dawn, the sky still undecided, when the sun does something it has done a billion times before. Except this time, it nudges Earth's atmosphere just enough to matter. You can't feel it on your skin. No breeze changes direction. No alarms go off. And yet, far above your head, the air itself quietly rearranges. You probably won't survive this. By which I mean, staying awake through the whole explanation is going to be a heroic challenge. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. Drop a comment with where you're listening from and what the local time is. Somewhere, someone else is also drifting off under the same restless star. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You walk forward in your imagination, straight up rather than ahead, rising through layers of air that normally feel fixed and dependable. The strange part is that what just changed isn't the atmosphere you breathe, but the one that barely counts as air at all. The sun has been busy lately. Bright flares, rippling magnetic fields, a general solar restlessness, and Earth responded the way it always does. Subtly, elastically, like a planet stretching in its sleep. A mainstream historical fact settles in early here. Scientists have known since the dawn of the space age that strong solar activity heats Earth's upper atmosphere, causing it to expand. This was first confirmed in the late 1950s, when early satellites began losing altitude faster than predicted. Engineers blamed bad math. The sun quietly blamed itself. You float past that moment now, watching metal spheres skim invisible air that had puffed up just enough to slow them down. What's new, what almost no one is talking about, is not that this happens, but that it just happened again, clearly, measurably, and during a time when most people were looking elsewhere. Solar Cycle 25 has been more energetic than early predictions suggested. Space weather instruments noticed. Atmospheric density models updated. Headlines mostly shrugged and moved on. You keep floating. You drift into the thermosphere, a region so thin it feels like cheating to call it an atmosphere at all. Here, individual molecules are spaced kilometers apart, and yet they respond dramatically to the sun. When ultraviolet and X-ray radiation increases, these lonely particles absorb energy, speed up, and push the whole layer outward. It's less like boiling water and more like a deep, slow inhale. Earth takes a breath. A quirky but true tidbit slides by. The thermosphere can reach temperatures hotter than molten lava, over 2,000 degrees Celsius, yet would feel freezing cold to a human body because there's almost nothing there to transfer heat. You imagine touching fire that doesn't burn, which is either poetic or deeply unfair. Probably both. As you hover, you notice that this atmospheric swelling doesn't announce itself. No thunder, no shaking ground. Instead, satellites feel a gentle drag, like swimming through syrup that was supposed to be water. Some need course corrections. Though a few tiny fragments of space junk spiral down sooner than expected, burning up in quiet, unreported streaks. Somewhere, an engineer sighs into their coffee. Joke one, the sun didn't break the atmosphere, it just slightly rearranged the furniture. Historians still argue whether similar solar outbursts in the past had noticeable effects on early technologies like telegraph systems or long-distance radio, or whether people simply blame the sun because it was convenient and already suspicious looking. You pass old accounts of wires sparking during auroras, operators shocked by their own equipment, and newspapers confidently declaring the end of modern communication. An early preview of the internet comment section. The change you're gliding through is real, but it's also temporary. The atmosphere expands, then relaxes. It's a pulse, yet not a wound. Still, there's something unsettling about realizing that the boundary between Earth and space is not fixed. It breathes with the sun. It listens. It responds. Joke 2. Earth doesn't ghost the sun. It texts back immediately. You look down now, toward the solid planet, and notice how insulated daily life is from all this. Weather continues, traffic happens, someone burns toast, The lower atmosphere barely notices the drama above. That separation is important, and scientists are careful to emphasize it. Upper atmosphere heating from solar activity is not the same thing as climate change. Not a hidden driver, not a secret override switch. The distinction is clear in the data, even if it's fuzzy in late-night conversations. And yet, the silence around this recent change lingers. Not because it's dangerous, but because it's subtle. Modern attention prefers sharp edges, crisis or nothing. A gradual, well-understood planetary response doesn't compete well with louder fears. Joke 3, the atmosphere did something impressive, and the algorithm said, meh. You slow your upward drift, suspend it in thin light, and let the idea settle. The sun changed Earth's atmosphere. It has always done so. It will do so again. What's different is simply that you're paying attention now, noticing the quiet mechanics of a living system that never really stops adjusting. The planet isn't fragile here. It's responsive. Your breathing steadies as the thermosphere's warmth fades into abstraction. The change has already begun to ease, the expansion gently receding as solar intensity ebbs. Nothing broke. Nothing panicked. Earth just listened to its star and answered in kind. You keep drifting without noticing a seam between moments, because the sun never really pauses long enough to give you one. It simply shifts moods. Right now you're watching it in a phase astronomers politely call active, which is a bit like calling a thunderstorm energetic. The sun rolls through these moods on a roughly 11-year rhythm known as the solar cycle, a mainstream fact that's been tracked since the 18th century, back when observers counted sunspots by hand and hoped clouds wouldn't ruin their notes. You hover close enough now to sense that this cycle isn't about brightness in the way a light bulb works. The sun's total output barely changes. Instead, it's the magnetic chaos that matters. Field lines twist, tangle, snap, and reconnect, releasing energy in flares and coronal mass ejections. From here, they look like slow-motion fireworks, but with consequences that reach all the way to your quietly expanding atmosphere back home. Solar cycle 25, the one you're currently living through, was predicted to be mild. Many models expected a sleepy sun, the celestial equivalent of hitting snooze. Instead, it perked up early. Sunspot numbers climbed faster than expected, and flares arrived with casual confidence. Not catastrophic ones, nothing movie-worthy, but enough to dump extra energy into Earth's upper air. You imagine scientists blinking at their screens, then nodding because the sun has always enjoyed ignoring confident predictions. A quirky historical tidbit floats by. During the Maunder minimum in the 1600s, sunspots nearly vanished for decades, coinciding with colder winters in parts of Europe. People blamed witches, bad harvests, and divine disappointment long before anyone blamed the sun. Historians still argue whether that solar lull meaningfully contributed to the so-called Little Ice Age, or whether climate just used the timing as a convenient coincidence. You feel the present-day contrast. Now the sun is anything but quiet. Its surface crackles with activity, sending bursts of ultraviolet radiation that reach Earth in about 8 minutes, faster than most people decide what to have for breakfast. That radiation doesn't stop at the ozone layer. It barrels upward into the thermosphere, where it's absorbed eagerly, converting light into heat and heat into expansion. There's a temptation, you notice, to imagine the sun as deliberately mischievous, not like it's picking on Earth specifically. But from this vantage point, the truth is more boring and more comforting. The sun does this to everything nearby. Mercury gets scorched, Mars gets stripped a little at a time. Earth just happens to have the right combination of magnetic field and atmosphere to turn solar tantrums into manageable shivers instead of existential crises. Joke 1. Earth didn't win the cosmic lottery. It just read the instructions. You pass through invisible magnetic shields now, the magnetosphere bowing outward under solar pressure like a bubble in a strong wind. This deflection is another mainstream fact, confirmed by decades of satellite measurements. When the solar wind intensifies, Earth's magnetic field compresses on the day side and stretches into a long tail on the night side. Energy funnels down toward the poles, where it paints auroras and heats the upper air even more. A fringe idea drifts past here too, whispered in speculative papers and late-night forums. That repeated solar storms might, over geologic time, erode Earth's atmosphere the way Mars lost much of its own. Scientists mostly side-eye this notion for Earth, pointing to our strong magnetic field and active geology. Still, it lingers as a reminder that planetary protection isn't automatic. It's earned moment by moment, orbit by orbit. You notice how small the changes still are. Even during heightened solar activity, the total expansion of the atmosphere is measured in tens of kilometers, which sounds dramatic until you remember the planet is over 12,000 kilometers wide. Perspective matters. It joked too. The atmosphere didn't balloon. It just loosened its belt after a big meal of sunlight. Down below, almost no one feels compelled to care. The sun rose. The day happened. News cycles chewed on louder stories. Space weather bulletins stayed mostly within scientific circles, read by people who already expect the sun to behave badly from time to time. There's no villain here, no countdown clock, just a star doing what stars do. Historians still argue whether ancient civilizations noticed long-term patterns in solar behavior and encoded them into myths, calendars, or rituals, or whether humans simply see patterns wherever fire and fear overlap. You drift past petroglyphs that might depict sunspots, or might just be circles because circles are fun to carve. As you continue onward, the sun's restlessness no longer feels alarming. It feels familiar. Cycles rise, cycles fall. Earth adjusts without complaint. The recent atmospheric change was less a shock and more a reminder. Your planet lives under a variable star, and variability is the price of warmth, light, and life. You let that settle as the sun's glow softens behind you, not dimming, just momentarily less demanding. The rhythm continues, and you drift with it, unhurried. You don't stop moving upwards so much as you stop thinking of up as a direction. The atmosphere thins around you in layers that sound tidy on diagrams, but blur in real life, like watercolor edges bleeding into one another. You pass through them anyway, feeling the gradient more than seeing it, because this is where the sun's recent nudge actually mattered. Closest to the ground is the troposphere, where clouds loaf around and weather throws its daily tantrums. Above that sits the stratosphere, home of the ozone layer and the occasional rogue balloon. Higher still, the mesosphere quietly incinerates meteors like a cosmic fly swatter. None of these layers flinched much when the sun acted up. The change you're following waited patiently until you reach the thermosphere, starting around 80 kilometers up, where air stops behaving politely. A mainstream fact anchors you here. Over 90% of atmospheric mass sits below 16 kilometers. Everything above that is, by comparison, a rumor. And yet, this rumor is where solar energy goes to work. The thermosphere absorbs extreme ultraviolet radiation, which means it takes the hit so the lower layers don't have to. Earth's atmosphere, you realize, is structured like a sacrificial shield that barely anyone thinks about. As solar radiation increased recently, this upper layer heated and expanded. Molecules move faster, spacing themselves farther apart, pushing the boundary of space outward. Satellites that normally cruise through near vacuum found a little more resistance than expected. Not enough to panic, just enough to notice. Somewhere, a spreadsheet quietly updated its numbers. A quirky tidbit floats by. The Kármán line, often called the edge of space, sits at 100 kilometers, but it's a human invention, not a physical wall. On energetic solar days, the atmosphere can swell above it, meaning some spacecraft technically dip into air while still being very much in space. Space, it turns out, is negotiable. Joke one, even the atmosphere refuses to respect arbitrary lines on a chart. You linger where day turns into night every 90 minutes, watching sunlight energize particles on one side of the planet while darkness lets them cool and sink on the other. This daily breathing overlaps with the solar cycle breathing you've already noticed. Layers within layers, rhythms stacked like slow waves. It's beautiful in a way that doesn't demand attention, which may be why it rarely gets any. Historians still argue whether early rocket scientists fully understood just how variable the upper atmosphere could be when they launched the first satellites, or whether success arrived partly by luck. Some early missions decayed faster than expected, and only later did solar activity take the blame. At the time, It must have felt like the sky itself was changing the rules mid-game. You notice how temperature works differently here. In the thermosphere, temperature reflects energy per particle, not how hot it would feel. Two particles can be screaming fast and they still fail to warm you. This confuses almost everyone the first time they learn it, which is comforting. Joke 2. If physics feels unintuitive, congratulations, you're paying attention. Below you, life remains wrapped in thicker air, blissfully unaware. Above you, space thins into near nothing. You're hovering in the in-between, the place that changed when the sun stirred. The expansion wasn't dramatic, but it was precise, predictable, and well within the bounds of what Earth has handled for billions of years. A fringe idea drifts through your thoughts. Some speculate that long-term variations in upper atmosphere density could subtly influence the rate at which small meteoroids burn up, possibly affecting how much cosmic dust reaches the surface. Most scientists consider this effect negligible, but it's the kind of thought that keeps someone staring at the ceiling at 3 a.m., wondering how many things quietly work in their favor. Joke 3 slides in gently. The atmosphere did not collapse, flip, or escape. It just did a little stretch, like someone waking up and reaching for the edge of the bed. You begin to sense the continuity now. The sun adds energy. The upper atmosphere responds. Satellites adjust. The planet carries on. No layer exists in isolation. Each depends on the others staying where they are. And the recent change didn't rewrite the rules. It followed them perfectly. As you drift onward, the layers blur again, and the idea settles in your mind that Earth's atmosphere isn't a static shell. It's a dynamic system, always shifting, always listening upward. The sun spoke. The upper air answered. And now, slowly, patiently, it relaxes back toward its usual shape. You don't hear the collision when it happens, because sound needs thick air, and you are long past that luxury. What you sense instead is a gentle chaos, a place where particles that almost never meet suddenly do, nudged together by the sun's insistence. This is where solar storms stop being abstract charts and start becoming physical events, even if they remain invisible to everyone below. A solar storm, despite the dramatic name, it is mostly a flood of charged particles and intensified radiation carried outward by the solar wind. When this wind strengthens, it slams into Earth's magnetic field and squeezes it, funneling energy toward the upper atmosphere. A mainstream fact slides into place here. During strong geomagnetic storms, the thermosphere can heat by hundreds of degrees within hours. The molecules don't combust or glow dramatically. They just move faster, colliding more often, passing energy along like whispered gossip. You drift through this energized region, watching oxygen and nitrogen atoms absorb ultraviolet photons and turn them into motion. This is the engine of expansion. Faster particles mean a puffier atmosphere, which means the boundary between Earth and space creeps outward. It's physics doing exactly what physics always does. No surprises, just scale. A quirky tidbit surfaces. During intense solar storms, the upper atmosphere can expand enough that the International Space Station experiences noticeably increased drag, requiring periodic boosts to stay aloft. Astronauts don't feel this directly. They're too busy floating. But ground teams keep a closer eye on fuel budgets when the sun gets rowdy. Joke 1. Even in orbit, the sun finds ways to make you burn a little extra gas. You notice that these collisions aren't violent in the cinematic sense. There's no smashing, no sparks. It's more like a crowded dance floor where everyone suddenly starts moving faster. Bumps happen more often. Energy redistributes. The whole room subtly swells as elbows and shoulders demand more space. Earth's upper atmosphere becomes that room. Historians still argue whether the famous Carrington event of 1859, the most powerful recorded solar storm, caused a comparable expansion of the thermosphere, or whether we simply lack the measurements to say for sure. Telegraph systems failed spectacularly, auroras lit up tropical skies, and operators reportedly unplugged equipment that continued working anyway. The atmosphere, meanwhile, left no diary behind. You glide through regions where electrons spiral along magnetic field lines, dumping energy into the air near the poles. This polar focus is why auroras appear where they do, and why atmospheric heating is uneven. The sun doesn't warm Earth like a blanket. It pokes it with glowing fingers. Some areas respond more than others, but the system balances out over time. Go, a fringe idea murmurs at the edge of your awareness that repeated heating and cooling cycles might subtly change the chemical composition of the upper atmosphere, affecting how long certain gases linger. Researchers study this carefully, mostly concluding that Earth's atmosphere is remarkably good at maintaining its mix. Still, the question lingers because the sun never stops poking. Joke 2 drifts in. If the atmosphere had a status update, it would read, "It's complicated." Below you, radio waves bend and bounce through layers whose densities just shifted a little. High-frequency communications notice. GPS timing corrections adjust by tiny amounts. Most users never see the hiccup, but engineers do, and they quietly thank the models that predicted it. This is one reason the recent atmospheric change mattered. Not because it was dangerous, but because it reminded technology that space is not empty and not constant. You slow your drift, feeling the storm's energy dissipate. Solar storms pass, the wind weakens, the atmosphere cools and contracts, returning toward its baseline. No permanent scar remains. Earth has weather up here too, and like all weather, it changes. Joke 3 lands softly. The sun threw a party, the upper atmosphere danced too hard, and now everyone is hydrating and sitting down. As the collisions grow less frequent, the expanded air begins to settle. Satellites resume their expected paths. Models relax their margins. From the ground, nothing ever looked different. That disconnect between dramatic physics and everyday silence is part of why almost no one noticed. You drift onward, carrying with you the sense that Earth's response to the sun is both intimate and controlled. Energy arrives, particles collide. The atmosphere swells, then sighs. A conversation conducted entirely above your head, every day, whether you're listening or not. You follow the consequences rather than the cause now, drifting sideways into the thin lanes where satellites circle the planet like patient moths. This is where the atmosphere's recent change made itself known in the most practical way possible. Not with drama, but with paperwork. When the upper air puffed up, even slightly, it reached into orbits that normally feel safely empty. A mainstream fact anchors the moment. Low Earth orbit is not a vacuum. At altitudes of 200 to 600 kilometers, there is always a whisper of atmosphere, and its density rises and falls with solar activity. When the thermosphere expands, satellites experience increased drag, losing altitude faster than expected. This has been measured repeatedly since the earliest space missions, and it's one of the reasons satellite operators obsess over space weather forecasts. You drift alongside a satellite as it glides through air that isn't supposed to be there today. The resistance is tiny, but relentless, like swimming with a sock on your hand. Over days and weeks, that drag adds up. Orbits decay, calculations change, thrusters fire in brief, precise nudges to restore the path. Joke 1. Space may be hard, but accounting for the atmosphere is harder. The recent solar activity caused just such nudges. Nothing emergency level, nothing newsworthy, but enough that multiple satellites required extra attention. The International Space Station, Earth observing platforms, even defunct hardware tumbling without control all felt the same gentle tug. Some pieces of space junk were pulled lower, entering denser air and burning up earlier than predicted. An unintentional cleanup effort sponsored by the sun. A quirky tidbit floats in here. During periods of strong solar activity, the number of tracked orbital objects can actually decrease because atmospheric drag helps clear out debris. Space agencies quietly appreciate this side effect, even if they'd never phrase it that way publicly. It's like gravity's spring cleaning service, operating on a very long schedule. Historians still argue whether early satellite losses in the 1960s were more influenced by poor atmospheric models or by unexpectedly active solar conditions. Back then, the upper atmosphere was still a mystery, its density inferred indirectly from how quickly spacecraft slowed down. Engineers learned the hard way that space was not as empty as advertised. You watch numbers scroll past, altitude, velocity, drag coefficient, while the planet spins below, oblivious. This is one of the reasons the recent atmospheric change mattered, even if almost no one talked about it. Modern infrastructure leans heavily on objects that skim the edge of space. weather forecasting, navigation, climate monitoring, global communications, all of it depends on satellites behaving predictably in an environment that quietly refuses to stay still. A fringe idea hums faintly. Some researchers have suggested deliberately timing satellite launches and orbital maneuvers to coincide with lower solar activity, minimizing drag and extending mission lifetimes. It's debated how practical this really is, given launch schedules, budgets, and the sun's habit of ignoring calendars. Still, the idea persists because fuel saved is mission time earned. Joke 2 drifts by. The atmosphere doesn't hate satellites. It just likes to remind them who owns the place. You sense the balance here. Increased drag is inconvenient, but not catastrophic. It's a known variable, folded into planning and simulations. The sun's recent behavior stayed well within historical bounds. Operators adjusted, models updated, and the system absorbed the change the way it was designed to. Down on Earth, no one felt a thing. But GPS kept working. Weather apps refreshed. Streaming videos buffered, if at all, for entirely unrelated reasons. The drama stayed aloft, contained in spreadsheets and control rooms. Joke 3 lands gently. The satellites noticed. The engineers noticed. And everyone else kept scrolling. As the atmosphere slowly contracts again, drag decreases, orbits stabilize. The sun moves on to its next mood. You drift away from the satellites, carrying the quiet understanding that Earth's atmosphere doesn't just shape life below. It reaches upward, tugging on our machines, reminding them they are still very much part of the planet. You slow your drift and let a solid certainty settle in, because this is one of the rare moments where the science doesn't wobble. There is no controversy here, no raised voices in conference halls, no dueling headlines. A mainstream fact stands calmly at the center. Increased solar activity causes Earth's upper atmosphere to heat and expand, increasing atmospheric density at satellite altitudes. This has been observed directly, repeatedly, and for decades. You watch how this knowledge crystallized. Early space missions in the late 1950s and early 1960s noticed that satellites lost altitude faster during periods of high sunspot numbers. As more data accumulated, the pattern became undeniable. Solar ultraviolet radiation went up, thermospheric temperature rose, density increased, drag followed. Cause and effect lined up so neatly it almost feels suspicious, but physics is sometimes like that. A quirky historical tidbit drifts by. One of the earliest confirmations of this effect came from tracking Sputnik's orbit. Its unexpected orbital decay helped scientists realize that Earth's upper atmosphere was far more dynamic than previously thought. Sputnik didn't just beep, it taught. Joke 1, even the first satellite had to pay the atmosphere tax. You hover beside modern instruments now, satellites dedicated not to communication or imaging, but to watching the atmosphere itself. Accelerometers detect tiny changes in drag. Ultraviolet sensors measure incoming solar energy. Models assimilate this data in near real time, adjusting predictions. When the recent solar uptick happened, these systems didn't panic. They nodded, logged it, and carried on. Historians still argue whether early atmospheric models underestimated the role of solar variability because of limited data or because scientists were biased towards simpler assumptions. Either way, those early mistakes became lessons. Today's models are sophisticated enough to anticipate expansion events within tight margins, even if the exact timing of solar outbursts remains stubbornly unpredictable. You sense why this recent change didn't make headlines. It didn't break expectations, it confirmed them. There's something almost boring about being right, especially when being right means nothing visibly bad happened. The atmosphere expanded, satellites adjusted, and the planet kept spinning. No cliffhangers, no villains. A fringe idea wanders through the edges of this certainty. Some researchers explore whether long-term trends in upper atmosphere density could serve as indirect indicators of broader solar behavior, almost like reading the sun's mood through Earth's response. It's an intriguing thought, but one still very much in the exploratory phase. Joke 2 floats by. The atmosphere didn't surprise scientists. It sent a calendar invite and followed the agenda. You glance downward again, and the separation between scientific importance and public awareness becomes obvious. The change mattered to those who needed to know. For everyone else, it was background noise at a frequency they don't tune into. That's not ignorance, it's triage. Humans can't pay attention to everything, especially when the consequences are gentle. You feel a calm confidence in this section of the story. The sun did what the sun does. Earth responded exactly as theory said it would. Instruments confirmed it. Models absorbed it. This is science at its least dramatic and most reassuring. Now, joke 3 lands softly. Sometimes nothing to worry about is the most accurate headline and the least clickable. As you drift onward, you carry this anchor with you. Whatever else is debated, speculated, or misunderstood, this part is solid. The sun changed Earth's atmosphere, yes, but in a way that fits neatly into a well-understood pattern. The quietness isn't neglect, it's familiarity. You move now toward the watchers, the quiet sentinels that notice the change without flinching. No breaking news banners, no dramatic countdowns, just instruments doing what they were built to do. Measure, compare, remember. This is where Earth's atmospheric shift was recorded, pixel by pixel, number by number, while most of the planet slept. A mainstream fact settles in. Modern space weather monitoring relies on a network of satellites and ground-based observatories that continuously track solar radiation, magnetic fields, and atmospheric density. Missions like these don't wait for something exciting to happen. They assume it will. When the sun's activity ticked upward recently, the data streams reflected it almost immediately. You drift beside a satellite equipped with an accelerometer, so sensitive it can feel forces smaller than a human breath. As the upper atmosphere expanded, drag increased just enough for the instrument to notice. Not dramatically, just a slight, persistent tug. That tug became a data point. Thousands of data points became a pattern. The pattern matched expectations, logged, filed, quietly important. A quirky tidbit floats by. Some of the most precise measurements of atmospheric density come from satellites that were never designed for that purpose. By tracking how their orbits decay, scientists can back-calculate how thick the upper air must be. It's like learning about wind by watching how laundry flaps, except the laundry costs hundreds of millions of dollars. Joke 1. The atmosphere refuses to be measured directly, so scientists politely spy on it instead. Down on Earth, magnetometers record subtle wobbles as solar energy couples into the planet's magnetic field. Radio telescopes monitor solar emissions. GPS ground stations detect tiny timing errors caused by atmospheric changes above. Each system sees only part of the picture, but together they confirm what's happening. The sun pushed, the atmosphere responded. Historians still argue whether early civilizations could have noticed similar atmospheric responses indirectly, perhaps through changes in auroral frequency or unusual sky colors, or whether such variations would have blended into the background of myth and weather lore. Without instruments, subtlety leaves no receipts. You notice how unexcited the modern response feels. Scientists don't gasp. They don't rush to social media. They compare plots, check calibration, and move on. This is not apathy, it's confidence. When a system behaves as predicted, the correct reaction is calm. A fringe idea hums quietly here too. Some researchers speculate about using upper atmosphere changes as an early warning proxy for extreme solar events, catching patterns before the most disruptive effects arrive. It's debated how much lead time this could realistically provide, but the idea lingers, because even minutes can matter in space weather. Joke 2 drifts in. The instruments noticed immediately, because unlike humans, they never blink. You think about headlines now and why they never came. No single instrument saw something shocking. No threshold was crossed. The story existed only in aggregate, in trends, in deviations from baseline, in the gentle agreement between independent measurements. That kind of story doesn't shout. It whispers to people who already know how to listen. As solar activity eased, the instruments recorded that too. Density values drifted back toward normal. Drag lessened. Magnetic indices relaxed. The atmosphere's stretch ended without ceremony. The watchers stayed alert anyway. Up because the sun never promises it's done. Joke 3 lands softly. The most dramatic space events often end with a shrug in a well-labeled graph. You drift away from the instruments with a new appreciation for how much of reality is monitored without applause. The sun changed Earth's atmosphere, and a small community noticed immediately, confirmed it carefully, and said very little, because everything was working exactly as it should. You drift now into the space where stories usually form, and you immediately notice the absence of one. This is the part where something important happened. Measurements were taken, consequences followed, and yet almost no one talked about it. Not because it was hidden, and not because it was denied, but because it didn't fit the shape of modern attention. And a mainstream fact settles gently here. Most scientific findings, even planet-scale ones, unfold gradually and predictably, making them poor candidates for headline news. The recent atmospheric expansion didn't arrive with a single dramatic moment. It emerged as a curve on a graph, a slow rise in density values, a confirmation of expectations. Newsrooms trained to chase novelty and conflict glanced at it and moved on. You imagine editors asking the unspoken question, "What's new here?" The honest answer, "The sun did what it always does and Earth responded normally," is accurate, but not clickable. There was no danger to fear, no action to demand, no villain to blame. The atmosphere stretched politely and then settled back down. It's hard to sell calm. A quirky tidbit drifts past. In the early days of newspapers, re-reports of auroras and sunspots were often tucked into almanacs or farmers' notes, listed alongside tide tables and planting advice. Celestial behavior was treated as background context, not breaking news. In some ways, the modern silence is a return to that older attitude. Historians still argue whether the public's perception of space weather has become more distorted in the satellite age, either exaggerated into apocalyptic scenarios or ignored entirely unless something breaks. The middle ground, where subtle but important processes live, tends to vanish. You float through the digital noise of the present, constant alerts, urgent banners, notifications competing for a narrow slice of attention. Against that backdrop, a predictable atmospheric response doesn't stand a chance. Even when scientists mention it, or they do so in technical language, cautious and precise, which further dampens its spread. Accuracy is rarely viral. A fringe idea flickers here too. Some argue that repeated underreporting of benign space weather events may leave the public unprepared for a truly extreme one. Others counter that constant reporting would only desensitize people. The debate has no clean resolution, just differing philosophies about awareness and fatigue. Joke 1 drifts in. The atmosphere changed, but it forgot to include a jump scare. You notice another reason for the silence. The change didn't touch daily life. Flights didn't cancel, power grids didn't fail, phones didn't stop working. When consequences remain invisible, curiosity rarely ignites. Humans evolved to notice fire and thunder, not expanded thermospheric density. So joke 2 lands softly. If it doesn't affect coffee, traffic, or Wi-Fi, it barely exists. Yet here you are, following the thread anyway, and realizing that this quietness is not neglect, but filtering. Civilization depends on layers of experts paying attention so that everyone else doesn't have to. The watchers noticed. The system adjusted. Silence followed because silence meant success. Historians still argue whether future generations will look back and see this era as unusually disconnected from natural cycles, or simply overwhelmed by information. Either way, the sun kept doing its thing, unconcerned with coverage. Joke 3 drifts by. The atmosphere whispered, science nodded, and the internet asked for something louder. You let that sink in as you drift onward. Not every planetary change needs a spotlight. Some are meant to be understood quietly, appreciated by those who listen closely, and then allowed to fade back into the steady hum of a functioning world. You keep drifting, and the present thins just enough for the past to seep in. Not the dramatic past of kings and wars, but the quieter one where people looked up and noticed the sky doing something unusual, long before anyone could measure atmospheric density or solar flux. This is where a strange parallel lives, faint but persistent. A mainstream historical fact settles first. Strong solar activity has, on multiple occasions, produced auroras visible far beyond their usual polar homes. Records from Europe, Asia, and North America describe shimmering lights appearing at surprisingly low latitudes during periods of intense geomagnetic disturbance. These events were real, widespread, and deeply confusing to the people who saw them. You imagine standing in a medieval field, the night sky suddenly rippling with color. No satellites, no equations, just light where light does not belong. When the sun recently nudged Earth's atmosphere, the same underlying physics was at work. Charged particles guided by magnetic fields, energy poured into the upper air. The difference now is not the mechanism, but the interpretation. A quirky historical tidbit drifts by. During the great auroral displays of the late 18th and 19th centuries, some observers believed the lights were reflections of distant fires, supernatural armies, or omens of political upheaval. One report from 1770 describes people waking neighbors in panic, convinced the horizon was burning. Joke 1. When you don't have space physics, everything looks like the apocalypse. Historians still argue whether these dramatic auroras coincided with measurable changes in the upper atmosphere, similar to what satellites observe today, or whether the lack of direct data makes such connections speculative. What's clear is that the sun was active, Earth's magnetic environment was energized, and the atmosphere responded, just as it always does. You feel the echo now. The recent atmospheric expansion didn't produce globally shocking auroras, but it did intensify them slightly, extending their reach on certain nights. A few photographers noticed. Most people slept through it. The sky whispered again, and only some were listening. You drift through old sketches of auroral curtains drawn by hand, attempts to capture something that refused to stay still. These drawings are imperfect, but they're data in their own way. They tell us that Earth has always lived under a variable sun, and that the atmosphere has always been part of the conversation. A fringe idea hovers here. Some researchers have explored whether long-term records of auroral sightings could serve as indirect proxies for past solar activity, helping reconstruct centuries of solar behavior. It's debated how reliable such records are, given cultural interpretation and uneven documentation. Still, the effort continues because even imperfect memory is better than none. Joke 2 drifts in gently. Before satellites, the atmosphere's changelog was basically vibes and sketches. You notice how the emotional response has shifted over time. What once inspired fear or awe now inspires, at most, a push notification for Northern Lights visibility. Knowledge has dulled the drama, but it has also added comfort. When the sun acts up, you no longer have to wonder if the sky is warning you. It's just physics being expressive. Historians still argue whether humanity lost something when celestial events became routine explanations instead of mysteries, or whether the trade, fear for understanding, was unequivocally worth it. The atmosphere doesn't weigh in. It keeps responding either way. Joke 3 settles softly. The sky used to shout. Now it sends a polite email. As you drift onward, the parallel becomes clear. Then and now, the sun stirs. Then and now, the upper atmosphere answers. The difference is that, today, the response is logged, graphed, and quietly filed away, rather than etched into memory as a night when the heavens behaved badly. The sun changed Earth's atmosphere recently, just as it has many times before. The only real surprise is how calm the world has become about it, and how easy it is to miss something beautiful when it behaves exactly as expected. You drift back toward the poles, because that's where the atmosphere tends to show its feelings. If the recent solar activity left a visible signature anywhere, it was here, in the slow, luminous breathing of auroras that behaved just a little differently than usual. Not wildly, not dramatically. Just enough to notice, if you were already looking. A mainstream fact settles in. Auroras form when charged particles from the sun are guided by Earth's magnetic field into the upper atmosphere, where they collide with oxygen and nitrogen, causing those gases to glow. During periods of increased solar activity, more energy reaches these regions, often making auroras brighter, more dynamic, or visible at slightly lower latitudes. This connection is well understood and carefully monitored. You hover beneath curtains of green and red light that ripple like fabric underwater. During the recent atmospheric expansion, these lights intensified on certain nights, stretching farther than expected, lingering longer than forecast. To most people, this passed unnoticed. To aurora watchers, it felt like the sky leaning closer. A quirky tidbit floats by. Different auroral colors correspond to different gases and altitudes. Green from oxygen around 100 kilometers up, red from oxygen higher still, and rare purples from nitrogen. When the upper atmosphere expands, these emission layers shift subtly in height, changing how the aurora looks even if its overall intensity stays the same. Oh, joke one. The atmosphere didn't change outfits, it just adjusted the lighting. You notice how uneven the effect is. One location gets a spectacular display, another sees nothing. Clouds intervene. Light pollution drowns it out. The atmosphere may glow, but whether anyone sees it feels almost arbitrary. Beauty, like data, depends on timing and position. Historians still argue whether unusual auroral behavior in historical records, odd colors, unexpected shapes, reflects genuine atmospheric differences during extreme solar events, or simply the limits of human description. Without cameras, everything glows strangely, and strangely covers a lot of ground. You drift alongside modern aurora forecasts now, probability maps glowing on screens, percentages rising and falling. During the recent solar uptick, when those percentages crept higher than average, some people traveled, some stayed up too late, some caught a glimpse and felt briefly connected to something much larger than their day. Most never knew anything unusual happened at all. A fringe idea hums faintly here. A few researchers have explored whether subtle long-term changes in auroral patterns could indicate shifts in Earth's magnetic field or upper atmospheric composition. It's a delicate signal buried in noise, and opinions vary on how meaningful it really is. Still, the idea persists because auroras are one of the few atmospheric responses you can actually see. Joke 2 drifts in softly. The sky put on a show, but didn't advertise the time. You sense how this ties back to the silence surrounding the event. Horn auroras are one of the few solar-driven phenomena that reliably capture attention, and even they need cooperation from weather, darkness, and human patience. When they behave only slightly differently, the moment slips through unnoticed. Historians still argue whether future generations, armed with constant imaging and data, will find modern auroral events mundane or more meaningful than ever. Does knowing the mechanism cheapen the wonder or deepen it? The lights themselves don't care. They shimmer either way. Joke 3 lands gently. Understanding why the sky glows doesn't make it stop glowing. It just lets you relax and enjoy it. As the auroras fade back into their usual rhythms, the atmosphere cools and contracts, settling after its brief solar-stimulated stretch. The lights dim. The night returns to normal. Somewhere, someone scrolls past an image they don't realize was just a little rarer than usual. You drift onward, carrying the afterimage with you, a reminder that even subtle atmospheric changes can paint the sky differently, if only for those who happen to look up at the right moment. You drift into a quieter space now, where certainty softens at the edges and conversation replaces conclusion. This is where the data ends and interpretation begins, and where scientists lower their voices just a little, not out of doubt, but out of respect for complexity. This is the part of the story that never fits neatly into a headline. A mainstream fact steadies you first, while modern instruments precisely measure solar activity and atmospheric response today. Our understanding of how similar events played out in the distant past is necessarily incomplete. Satellites have only been around for a few decades. Before that, Earth's upper atmosphere left no direct record of its own behavior. Historians still argue whether solar-driven atmospheric changes had any meaningful impact on early technologies, ecosystems, or human activity before the space age. Telegraph disruptions during the 19th century are well documented. But whether those disturbances were caused purely by geomagnetic effects or also by changes in the upper atmosphere remains debated. The atmosphere, as always, kept its notes to itself. You float through academic papers where phrases like suggests, may indicate, and cannot be ruled out appear with comforting regularity. This isn't weakness, it's honesty. Scientists know exactly how today's atmosphere reacts to solar input. But reconstructing yesterday's reactions is like inferring a storm from the shape of puddles left behind. A quirky tidbit drifts by. Some researchers have examined tree rings and ice cores for indirect clues of past solar activity using cosmic ray signatures as a proxy. These records tell us when the sun was more or less active, but they don't tell us precisely how Earth's upper atmosphere expanded or contracted in response. It's like knowing how loud the music was without knowing who danced. You sense the tension here, not disagreement, but curiosity. Did stronger solar cycles subtly influence atmospheric chemistry centuries ago? Could they have affected radio wave propagation once wireless communication emerged? Did ancient observers notice patterns we now dismiss as coincidence? The questions persist, not because answers are missing, but because they're layered. Joke 1 floats gently through. The past is under peer review, and it's taking a very long time. A fringe idea hums at the margins. A handful of scholars speculate that long-term solar variability might have nudged atmospheric circulation patterns in ways too subtle to isolate today. Most of the field remains skeptical, emphasizing that Earth's lower atmosphere is dominated by internal dynamics. Still, the debate stays alive because complex systems rarely obey simple boundaries. You notice how differently this kind of uncertainty feels compared to fear-based unknowns. There's no threat here, no ticking clock, just an acknowledgement that even with satellites and supercomputers, Earth's full story stretches beyond direct observation. Joke 2 drifts in softly. Scientists aren't arguing because something's wrong. They're arguing because something's interesting. As you drift, you realize that the recent atmospheric change fits comfortably within this landscape. It doesn't challenge existing theory. It doesn't rewrite history. It simply adds one more well-measured moment to a record that is still, by cosmic standards, very short. Historians still argue whether future researchers will look back on this era as the moment humanity finally understood its relationship with the sun, or just the beginning of a much longer conversation. Either way, today's quiet debates are part of that inheritance. Joke 3 settles in. The atmosphere didn't spark an argument, it just gave everyone more to footnote. You move on feeling oddly reassured. Uncertainty here isn't a gap, it's a gradient. And the sun, unconcerned with consensus, continues to shine, stir, and step back, leaving Earth to interpret the echo. You drift gently downward in focus, not in altitude, because this is where confusion tends to collect. Whenever the sun changes something about Earth's atmosphere, even subtly, a familiar question floats up from below. Does this mean something bigger is happening? It's a fair question, and one that deserves a calm answer. A mainstream fact settles first, like a hand placed lightly on your shoulder. Heating and expansion of the upper atmosphere due to solar activity is a short-term, reversible process and is fundamentally different from long-term climate change in the lower atmosphere. Different layers, different energy sources, different timescales. The sun's recent nudge did not warm oceans. Why shift jet streams or rewrite weather patterns? You hover between layers, feeling how separate their concerns really are. The thermosphere responds directly to bursts of solar radiation. The troposphere, the one with clouds, storms, and seasons, responds mostly to energy trapped by greenhouse gases and redistributed by complex circulation. One listens upward, the other listens inward. A quirky tidbit drifts by. During periods of high solar activity, the thermosphere can heat dramatically while the lower atmosphere remains completely indifferent. At the same time, during major volcanic eruptions, the lower atmosphere can cool noticeably while the upper layers barely register the event. Earth's atmosphere is less a single system and more a stack of loosely related neighborhoods. Joke 1. They share an address, not a group chat. Historians still argue whether early climate theories overemphasized solar variability because it was easier to observe than atmospheric chemistry. For much of scientific history, the sun felt like the obvious suspect behind any environmental change. Only later did measurements reveal how dominant greenhouse gases are in shaping long-term surface temperatures. You feel the importance of clarity here. The recent atmospheric expansion was real, measurable, and interesting. But it was not a climate signal. Confusing the two doesn't just mislead, it distracts. Scientists are careful to separate these discussions, not because one matters less, but because precision matters more. A fringe idea flickers at the edge. Some speculate that solar variability might amplify or dampen certain climate patterns indirectly. When this remains an area of active research, with most evidence suggesting the effect is small compared to human-driven factors. The debate continues quietly, without the urgency of alarm or denial. Joke 2 drifts in. Blaming climate change on the sun is like blaming your sleep schedule on the moon. Romantic, but not supported by the data. You notice how often complexity gets flattened in public conversation. A change anywhere in the atmosphere becomes, the atmosphere is changing. Full stop. But you're floating inside the nuance now, and it's calmer here. Different processes can coexist without contradicting each other. The sun can puff up the thermosphere for a few weeks or months. Greenhouse gases can warm the lower atmosphere for decades or centuries. Both statements can be true at the same time without sharing a cause. Joke 3 lands softly. Earth can walk and chew cosmic gum simultaneously. As you drift onward, the confusion fades, replaced by a steady understanding. The sun's recent influence was a reminder of how responsive the upper atmosphere is. Not a warning flare, not a hidden message, just a well-understood interaction playing out above most human concern. The planet remains layered, nuanced, and resilient, and you, suspended between those layers, can finally let the questions settle without anxiety. You drift into a place where altitude stops mattering and pacing begins to slow, because this is where the story softens its voice. Up here, the argument fades. The measurements blur into memory, and what remains is relationship, Earth and Sun, in their long, familiar exchange. A mainstream fact rests gently in the background. Changes in the upper atmosphere, even noticeable ones, rarely propagate downward in ways that affect daily life. The thermosphere can swell and settle without disturbing the winds that move clouds or the pressures that shape weather. Life below continues, buffered by layers that absorb, redirect, and calm the energy before it ever reaches you. You feel that buffering now, like insulation in a quiet house. The sun stirred, the upper air responded, and then the response faded, absorbed into routine. Earth is very good at this. Billions of years of practice will do that. A quirky tidbit drifts lazily past. The upper atmosphere is so responsive to the sun that scientists sometimes describe it as space weather's front porch. It's the first thing solar energy touches, and then the first thing to relax when that energy eases. Joke 1 softened. The atmosphere answered the door, checked the weather, and went back inside. Historians still argue whether humanity's increasing distance from natural cycles has made us calmer or simply less aware. In earlier centuries, the sky changing was an event. Now it's a data point. Whether that's loss or progress depends on where you're drifting when you think about it. A fringe idea hums faintly and then quiets. That modern humans might benefit from paying gentle attention to slow, non-threatening planetary changes. Not out of fear, but out of belonging. It's not a popular research topic, but it lingers in the background like a half-remembered thought. Joke 2 arrives and dissolves. The atmosphere did its thing, and no one needed to refresh the page. Now the pace truly eases. You imagine the thermosphere cooling, molecule by molecule, the extra energy radiating away into space. The expansion unwinds. Density returns to its usual pattern. Satellites glide more easily again. Instruments keep watching, but with nothing urgent to report. Down below, lights go out in windows. Traffic thins. Somewhere, someone yawns and rolls over, unaware that anything above them was ever different. And that's okay. This is how it's meant to work. Systems responding quietly so minds can rest. You breathe slowly now, matching the planet's rhythm rather than the sun's. Inhale, Earth receives energy. Exhale, Earth redistributes it. Nothing is stuck, nothing is spiraling. Just motion, response, release. The sun will stir again. The atmosphere will answer again. And most of the time, you won't hear about it because stability doesn't need an audience. Your thoughts loosen, details blur at the edges, the graphs fade into gentle light. What remains is the simple reassurance that the world is still doing what it has always done and doing it well. You don't need to stay alert for this part. The watchers are watching, the systems are adjusting. The night is allowed to be quiet. Joke 3, barely a joke now. The planet handled it. You can rest. You drift onward, unhurried, carrying that calm with you as the tone subtly shifts back from lullaby to low-volume curiosity. This is where ideas live that don't quite fit, where speculation hovers just outside consensus, and where scientists squint slightly, not in fear but in careful skepticism. A mainstream fact anchors you first. Earth's atmosphere is constantly losing small amounts of gas to space. This happens through well-understood processes like thermal escape and interactions with the solar wind. It's slow, steady, and nowhere near fast enough to threaten the planet's habitability. The atmosphere you rely on is not slipping away in any meaningful sense. Still, when the sun stirs the upper atmosphere, a fringe idea inevitably floats up. Could repeated solar activity over extremely long timescales erode Earth's atmosphere more than we expect? The comparison to Mars is irresistible. Mars lost much of its atmosphere, and the sun played a role. The question lingers, even if the answer keeps pointing toward reassurance. You hover in that comparison now. Mars is smaller, with weaker gravity and a mostly absent global magnetic field. Earth is larger, denser, magnetically shielded, and geologically alive. The differences matter. Earth's magnetic field deflects much of the solar wind. Its gravity holds on to fast-moving particles. Its atmosphere is constantly replenished by volcanic outgassing and chemical cycles. A quirky tidbit drifts by. Measurements show that Earth loses only a few kilograms of atmospheric gas per second to space, while the atmosphere itself weighs about 5 quadrillion tons. At that rate, you'd have to wait longer than the age of the universe to notice. Joke 1. The atmosphere isn't leaking, it's shedding lint. Historians still argue whether early planetary scientists underestimated the importance of magnetic fields when comparing Earth and Mars, or whether the lesson only became clear once spacecraft could measure solar wind interactions directly. Either way, the comparison taught humility. Similar-looking planets can behave very differently under the same star. You feel why this fringe idea persists. The sun's recent heating of the upper atmosphere feels like a reminder that Earth is not sealed. It's open to space, responsive, permeable at the edges. That openness invites imagination, especially when paired with dramatic stories from elsewhere in the solar system. But imagination meets data here, and data stays calm. Studies consistently show that while solar storms can temporarily increase atmospheric escape rates, the effect is small and transient for Earth. Once the storm passes, escape rates drop back to normal. The system self-corrects. Joke 2 drifts in gently. Earth didn't forget to lock the door. It just has very good weather stripping. You notice how scientists talk about this idea. They don't mock it. They don't amplify it. They test it, measure it, and then quietly file it under interesting but not concerning. That tone matters. It's the sound of a field that has looked closely and decided there's no reason to raise its voice. A fringe-adjacent thought hums nearby. Some researchers explore whether extreme solar events, far stronger than anything in recorded history, could briefly overwhelm Earth's defenses. These are hypothetical, boundary-pushing scenarios, useful for understanding limits rather than predicting outcomes. The consensus remains that Earth's atmosphere is robust against anything the sun is likely to throw its way in the foreseeable future. Why Joke 3 lands softly. The sun can be dramatic, but Earth has seen worse and stayed breathable. You drift through simulations now, colorful models showing particles streaming, fields bending, gases escaping in tiny polite amounts. Nothing catastrophic, nothing runaway, just motion within constraints. Down below, none of this speculation matters to daily life, and that's part of the point. The sun's recent influence didn't push Earth closer to a threshold. It nudged a system that has room to move. Flexibility is not weakness, it's design. Historians still argue whether humanity's fascination with atmospheric loss says more about our fear of fragility than about actual planetary risk. Perhaps we're drawn to these ideas because they remind us that not everything is guaranteed forever. Or perhaps because they let us imagine stakes that feel appropriately cosmic. You let the idea drift away without clinging to it. Earth is not Mars. The sun is not new. The atmosphere has endured far greater variability than this. The recent change fits comfortably within a long, stable pattern. As you move on, the fringe idea fades back into the background where it belongs, not dismissed, not feared, just understood in proportion. The atmosphere stretches, relaxes, and holds on, as it always has. You drift closer now to the things that hum quietly through everyday life, even if no one thinks of them as fragile. Signals, timing, invisible threads of coordination stretched around the planet. This is where the atmosphere's recent change brushed against technology. Not enough to alarm, but enough to remind. A mainstream fact settles in. Radio waves, GPS signals, and some communication systems pass through or reflect off layers of the upper atmosphere, particularly the ionosphere. Changes in atmospheric density and ionization, often driven by solar activity, can slightly alter how these signals travel. This has been known since the earliest days of radio communication. You float through streams of signals, bouncing and bending, their paths subtly reshaped by a thermosphere that's just a little warmer and a little thicker than usual. During the recent solar uptick, engineers noticed minor increases in signal delay and variability. Most of it was corrected automatically, faster than a human could notice. A quirky tidbit drifts by. GPS satellites don't just tell you where you are. They tell you when you are. With timing accuracy down to billionths of a second. Tiny atmospheric delays matter. During periods of increased solar activity, correction models work overtime to keep everything synchronized. Joke 1. The atmosphere tried to make everyone late, and the clock said no. Historians still argue whether early radio operators fully understood why signals sometimes faded, bent, or traveled unexpectedly far during periods of high solar activity. Before the ionosphere was discovered, the sky's behavior felt capricious. Only later did the pattern emerge. The sun was quietly adjusting the medium. You sense how resilient modern systems are? Redundancy, error correction, forecasting, all built with the expectation that the sun will misbehave from time to time. When the upper atmosphere expanded recently, these systems didn't fail. They flexed. So yet a fringe idea hums softly. Some worry that a truly extreme solar event could overwhelm even modern technological safeguards, disrupting navigation and communication on a global scale. Researchers study this carefully, modeling worst-case scenarios. The key word remains extreme. The recent atmospheric change was nowhere near that boundary. Joke 2 drifts in, the sun nudged the system, and the system replied, noted. You notice the asymmetry here. Technology depends on the atmosphere, but the atmosphere doesn't care about technology at all. It responds to physics, not convenience. That's why monitoring matters. It's not about control, it's about anticipation. Down below, people check maps, stream music, synchronize calendars, all without knowing how many small corrections happen to keep those services seamless. And the recent solar-driven atmospheric changes added a few more adjustments to the pile, then quietly receded. Historians still argue whether future technological societies will feel more or less vulnerable to solar variability as reliance on space-based systems grows. Will awareness increase, or will automation make the sun feel irrelevant? Until it isn't, the question remains open. Joke 3 lands gently. The atmosphere changed, the technology adapted, and the user blamed their Wi-Fi anyway. As the sun's activity eases, signal paths stabilize. Correction models relax. Engineers log the event and move on. For most of the world, nothing ever seemed different. You drift onward with the understanding that modern life is threaded through layers of air and space that are constantly in motion. The sun's recent influence was a reminder, not of danger, but of dependency, a quiet one, handled well. You drift back into a wider view now, far enough out that the details soften and the relationship becomes the focus again. Earth below, sun beyond. A simple arrangement that is anything but simple in practice. This is where the recent atmospheric change stops feeling like an event and starts feeling like a reminder of where you live. A mainstream fact settles calmly into place. The sun is a variable star. Its output fluctuates on multiple timescales, minutes, days, decades, and longer. Earth's systems evolved under that variability, not in spite of it. Life didn't arise next to a perfectly steady lamp. It arose beside something restless. You hover in that thought. Every breath you take is made possible by a star that refuses to behave the same way forever. The sun's recent activity, the atmospheric expansion it caused, the subtle technological adjustments that followed, all of it fits inside that long-standing arrangement. This is the deal Earth signed billions of years ago. A quirky tidbit drifts by. If the sun suddenly became perfectly stable, with no flares, no cycles, no magnetic storms, it would actually confuse a lot of our models. Variability is baked so deeply into solar physics that total calm would be the real anomaly. Joke 1. If the sun ever truly settled down, scientists would panic. Historians still argue whether early astronomers fully grasped that stars were dynamic objects like the sun, rather than fixed eternal points of light. For centuries, young change in the heavens was considered suspicious. Now change is the expectation. Stability is the question mark. You feel how perspective shifts when you zoom out. The atmosphere's expansion wasn't the sun acting up. It was the sun being the sun. Earth didn't suffer it. Earth accommodated it. Magnetic fields bent. Molecules sped up. Orbits adjusted. Everything stayed within the lanes it has practiced for eons. A fringe idea hums softly here. Some philosophers of science suggest that humanity's discomfort with solar variability reflects a deeper desire for predictability in a universe that doesn't offer it. We want the sky to behave. The sky prefers rhythm over rules. It's an interesting thought, filed somewhere between physics and psychology. This joke too floats in gently. Earth doesn't ask the sun to calm down. It just stretches and carries on. You look back at the recent event with this wider lens. The atmosphere changed. That's true, but it didn't signal a new phase, a turning point, or a warning. It signaled continuity. The same forces, the same responses, the same quiet competence. Down below, life unfolds in ignorance of most of this, and that's not a flaw. It's the outcome of successful buffering. Planets that don't buffer well don't get to host listeners drifting off to sleep. Historians still argue whether recognizing Earth as a system shaped by stellar variability will become more central to education and culture, or remain a niche understanding held by specialists. Either way, the sun will keep cycling, unconcerned with how it's framed. Joke 3 settles softly. The sun changed the atmosphere adjusted, and the universe called that a normal day. You drift onward, no longer surprised by the idea that Earth lives under a star that refuses to sit still. That restlessness isn't a threat, it's context. And in that context, the recent change feels less like news and more like background music, noticeable only when you pause long enough to listen. You drift into the future without accelerating, because predictions here are cautious by design. This is where scientists lower the brightness and widen the timeline, talking not about what just happened, but about what it might mean, carefully, conditionally, without drama. A mainstream fact steadies the view. Solar cycles rise and fall roughly every 11 years, and Earth's upper atmosphere responds in kind each time. Over the satellite era, this pattern has repeated cleanly, with no long-term upward trend in solar-driven atmospheric expansion. The recent change fits neatly into that repeating waveform. You hover over long graphs now, decades compressed into gentle hills and valleys. Each peak corresponds to a more active sun, each dip to a quieter one. The thermosphere swells and relaxes accordingly, like a tide responding to a distant moon. Nothing in the data suggests the tide is creeping higher with each cycle. A quirky tidbit drifts by. During especially quiet solar periods, the upper atmosphere can contract so much that satellites experience less drag than expected, extending their lifetimes. Some spacecraft launched at the right moment have benefited simply from the sun being in a calm mood. Joke 1, sometimes the best space weather is just a lazy star. Historians still argue whether long-term records will eventually reveal subtle changes in solar behavior across centuries, or whether the sun's variability is remarkably consistent over human timescales. Ice cores, tree rings, and cosmogenic isotopes hint at fluctuations, but translating those into precise atmospheric effects remains challenging. You feel the tone here, measured, unhurried. Scientists are not forecasting runaway expansion, atmospheric instability, or a new regime. Instead, they talk about refinement, better models, better coupling between solar physics and atmospheric response, better forecasting for satellites and systems that depend on the edge of space. A fringe idea hums at the margins. A few researchers explore whether extremely rare, why super intense solar events, far beyond anything recorded, could briefly push Earth's atmosphere outside its usual comfort zone. These studies are useful thought experiments, stress testing assumptions. The consensus remains that even such events would be temporary disruptions, not lasting shifts. Joke 2 floats by gently. Planning for the worst doesn't mean expecting it. It means liking your margins. You notice how resilience keeps coming up, not as a buzzword, but as an observed property. Earth's atmosphere has multiple ways to shed excess energy. Radiative cooling, chemical pathways, dynamic circulation. When heated, it doesn't spiral, it disperses. Down below, future-facing conversations focus on practicalities. How will increasing satellite traffic interact with solar-driven drag? How should mission planners adapt as low Earth orbit becomes more crowded? These questions matter far more than existential ones, because they're the ones people can actually answer. Historians still argue whether future generations will view this period as one where humanity finally learned to operate comfortably within a dynamic space environment, or merely the early awkward phase of that learning. Either way, the sun will keep cycling, and Earth will keep responding. Joke 3 settles softly. The long term looks a lot like the short term, just with better spreadsheets. As you drift onward, the future doesn't feel ominous. It feels iterative. The sun will change the atmosphere again. Scientists will notice. Systems will adjust. Knowledge will accumulate, one calm event at a time. The recent change wasn't a preview of instability. It was another data point in a long record of balance, a reminder that Earth's relationship with its star has depth, memory, and room to breathe. You drift now into the emotional tone of the people who watch the sun for a living, and what you find there is not urgency, but familiarity. This is the part that often gets lost outside the lab, the calm that comes from having seen something many times before. A mainstream fact settles gently. Space weather scientists classify solar activity using well-defined scales and thresholds. When the recent uptick occurred, it landed comfortably within categories that are considered manageable. No emergency protocols, no unprecedented readings, just a notch higher than average. You hover over control rooms and research offices where screens glow softly. Plots update, alerts arrive. Most are acknowledged with a nod rather than a gasp. This isn't because the scientists are numb, it's because the system behaved the way it's supposed to. Calm here is competence. A quirky tidbit drifts by. Some space weather forecasters liken their job to meteorology in slow motion. The sun is far away, its storms take time to arrive, and their effects unfold over hours or days. This pace allows for anticipation rather than reaction. Joke 1. It's one of the few forecasting jobs where the storm takes 8 minutes just to say hello. Historians still argue whether institutional memory in science, knowing what normal trouble looks like, prevents overreaction or sometimes leads to underestimation. In this case, the balance held. The event was noticed, contextualized, and absorbed. You sense why this calm matters. Panic spreads faster than particles. Overstating routine solar effects would erode trust, not build it. Scientists choose their words carefully, especially when nothing is actually wrong. A fringe idea flickers here too. Some argue that the culture of calm in scientific communities can make it harder to communicate genuine risk when it does arise. Others counter that consistent restraint is what makes warnings credible when they are truly needed. The debate remains, but the tone stays measured. Joke 2 floats in gently. When experts aren't yelling, it's usually a good sign. You think back to the recent atmospheric expansion. To a layperson, the sun changed Earth's atmosphere sounds alarming. To a space physicist, it sounds like Tuesday. Context transforms fear into routine. Down below, this calm rarely translates. Silence is often misread as neglect. In reality, it's confidence built on repetition. The sun has flared before. The atmosphere has expanded before. Nothing crossed a line that demanded escalation. Historians still argue whether modern society trusts quiet expertise enough, or whether it's more comfortable with louder narratives. Either way, the sun doesn't tailor its activity to communication strategies. Joke 3 lands softly. The atmosphere did something interesting, and the scientists said, "Yep." As you drift onward, you carry that tone with you. Calm is not dismissal, it's understanding. And in this case, understanding said there was nothing to fear, only something to note, file, and learn from. The world kept turning not because no one noticed, but because the right people did, and they knew exactly what they were looking at. Want you drift into a quieter contrast now, one that has nothing to do with physics and everything to do with scale. Human attention flickers fast and burns hot. The sun, by comparison, is patient beyond comprehension. This is where those two tempos brush against each other and fail to sync. A mainstream fact settles in. The sun will continue cycling for billions of years, slowly increasing in brightness over geologic time, but changing only subtly on human timescales. Earth's atmosphere, meanwhile, has survived impacts, ice ages, volcanic eras, and magnetic flips. Against that backdrop, a recent thermospheric expansion barely registers. You hover between timelines. On one side, news cycles measured in hours. On the other, stellar rhythms measured in decades, centuries, millennia. When the sun nudges the atmosphere, it does so on its own schedule, indifferent to whether anyone is watching or whether watching lasts long enough to matter. A quirky tidbit drifts by. If you compressed Earth's entire history into a single calendar year, modern humans would appear in the last half hour of December 31st. Satellite-era measurements would take up a few heartbeats before midnight. Joke 1, the sun has been doing this all year and we just tuned in. Historians still argue whether humanity's short attention span is a biological inheritance or a cultural artifact amplified by technology. Either way, it means that slow, steady planetary processes struggle to hold the spotlight. The atmosphere can change measurably and still lose the room to something louder. You feel how easy it is to miss the long view. The recent atmospheric change didn't compete with immediate concerns. It didn't interrupt routines. It didn't demand reaction. In a way, that's the highest compliment a planetary system can earn. A fringe idea hums faintly here. Some thinkers suggest that reconnecting human narratives to long-term natural cycles could reduce anxiety and restore perspective. Others argue that modern life simply doesn't allow for that kind of temporal patience. The debate lingers, unresolved. Joke 2 drifts in gently. The sun runs on a cosmic calendar, and humans keep checking their phones. You notice how this mismatch shapes perception. A sudden disaster commands attention because it fits our wiring. A gradual, well-managed change does not, even if it involves an entire planet. The sun changed the atmosphere. Short-in attention slid right past it, not out of denial, but out of design. Historians still argue whether future cultures will become better at holding multiple timescales in mind, or whether acceleration will only sharpen the divide. Perhaps the answer depends on how often people are invited to slow down long enough to notice. Joke 3 lands softly. Nothing went wrong, so nothing trended. As you drift onward, the silence around the event feels less like neglect and more like alignment. Earth handled it, systems adapted, life continued, attention moved on as it always does. The sun keeps cycling, the atmosphere keeps responding. Human awareness flickers in and out, catching fragments of a much longer story. Tonight at least you caught one, and that's enough. You drift gently back toward stillness, not toward the ground or the sun, but toward balance. This is where the motion resolves, where the atmosphere finishes its stretch and remembers its shape. Nothing snaps back, nothing rushes. The system simply eases, the way a long breath releases itself when there's no reason to hold it anymore. A mainstream fact settles quietly. When solar activity decreases, the upper atmosphere cools, contracts, and returns toward its baseline density. This recovery is as predictable as the expansion that preceded it. The recent change has already begun to unwind, molecule by molecule, energy radiating away into space where it can't bother anyone. You hover in that cooling. The frantic collisions slow. The extra drag fades. Satellites feel less resistance and slip back into their familiar rhythms. Instruments continue watching, and of course, they always do, but there's nothing urgent to say. The graphs slope gently downward. Baselines reclaim their territory. A quirky tidbit drifts by. Scientists sometimes refer to this process as the thermosphere relaxing, which sounds almost comically human for a region of near vacuum and charged particles. But the word fits. Systems under strain that return smoothly to equilibrium earn that kind of language. Joke 1. Even the atmosphere knows when it's time to unclench. Historians still argue whether future historians will mark such moments at all, or whether they'll blur into an unbroken record of solar cycles and atmospheric responses. This one won't stand out. It won't need to. Its value lies in how ordinary it was. You look back across everything you've drifted through, the sun's restless moods, the invisible layers above you, the collisions, the satellites tugged just a little, the instruments that noticed, the silence that followed. None of it demanded fear, none of it asked for action. It simply asked to be understood. A fringe idea flickers one last time and then dims. That perhaps the most important planetary events are not the catastrophic ones, but the quiet demonstrations of resilience. The moments when a system is stressed just enough to show its strength and then allowed to settle. Joke 2 floats in softly. The atmosphere changed, everyone did their jobs, and the universe checked works as intended. Down below, nothing needs to resume because nothing ever stopped. Life flowed through the event without noticing, which is precisely the point. As the planet absorbed the sun's attention and returned to form without passing the tension along. Historians still argue whether awareness of such subtle planetary processes will ever become common knowledge, or remain the domain of those who look upward for a living. Either way, the sun will continue to speak in energy, and Earth will continue to answer in motion. Joke 3, barely there now. Nothing dramatic happened, and that's the happy ending. You let the final image soften. The sun glows, steady and variable all at once. Earth turns, layered and responsive. The atmosphere rests in its familiar configuration, ready to stretch again when called upon. There's no alarm to wait for, no revelation coming. Just a planet doing what it has always done beneath a star that never learned how to sit still. And with that understanding settled comfortably in place, there's nothing left to track, analyze, or anticipate. The story has completed its loop. The system is calm. The night is quiet. You can let go now.